Hi, good day and welcome to my first video on kinematics that involve integration and differentiation. So let's get started. Before we actually do an official question, I just want to explain the basics. Here we have displacement, D for displacement, V for velocity, and A for acceleration. Now just to make sure that we don't confuse the terms, sometimes displacement and distance are different, first of all. But sometimes in questions, and I've seen it in textbooks too, they use distance and displacement interchangeably. Same thing goes for velocity and speed. And well, they will always call acceleration, acceleration, unless it's a deceleration, which means a negative acceleration. So let's say we were given the equation for displacement. If I want the formula for velocity, I have to differentiate displacement, and that will give me velocity. And if I take velocity and differentiate that equation, I will get acceleration. So as we go downwards the chart, we have to differentiate. However, if I am given acceleration and I want to find velocity, to go upwards, I will need to integrate. So if I am given velocity and I require the equation for displacement, I will have to take the equation for velocity and integrate it to get displacement. All right? And also, when you integrate, when we're going upwards, in other words, when you integrate, please remember to put a plus C. Right, another thing, since this topic involves integration and differentiation, you really should watch the integration and differentiation videos I made prior to this video. All right, so let's get started. I will be bringing this chart off and on the screen as we need it. I want everyone to read this first question. I kind of summarized it on the board over here on this side. What they're basically saying is that you have some point O and a particle, it could be a car, it could be a truck, whooshes past this point O at a velocity of 0.5 meters per second. Now, as soon as it passes this point, the experiment or the question has now started. So at this point, it should be noted that your time will be equal to 0. So at a time 0, when it passes point O, the particle has a velocity of 0.5 meters per second. Then they told you that the acceleration of this particle, they didn't give you a value, they gave you an equation to express the acceleration. And here's what they want you to do. They want you to prove that this particle comes instantaneously to rest when t or time is 5. Now, how do we know when something comes to rest? If something has come to rest, take my hand here, my hand is moving, but if it comes to rest, I am no longer moving, which means my velocity is equal to 0. So when something has ceased moving or is at rest, you can assume that your velocity is 0. All right, so let's put this on the I'm leaving this on the board for the question. So here they gave us the expression for acceleration, but I need an expression for velocity. So if I am given acceleration and I need the velocity, I need to integrate this equation. So let's integrate this entire equation. Whenever you integrate acceleration, you will get velocity. So now I have to integrate this entire expression. Now I'm just going to run through this quickly because I'm assuming that you understand integration or you at least watched the videos prior to this. When you integrate, we're integrating the letter A with respect to t. So when you integrate 1.4, since that's a constant, you will get 1.4 t. The power here for t is 1. So when you integrate that, you will get t squared, you have to add 1 to the power and divide by the new power. Now, since I'm finished integrating this, when you integrate, please always remember to put plus c. Let's try to simplify. So this here is my equation for the velocity. But we have a little problem. We don't know the value of c. We really need to figure out this value of c. But let me just simplify this as much as I could. 0.6 divided by 2 is obviously 0.3. So let's just simplify that. Right. Now, to find the value of c, they have to give us a hint. They have to give us a certain information. And they did. They said, not directly, of course, but from analyzing the question, that when time is 0, my velocity at the same point in time is 0.5. So that means when t is 0, I can replace t with 0, but the corresponding value for v is 0.5. So I'm going to replace my v with 0.5 and all my t's with 0. Right. So I can quickly solve for t, and it's going to be super easy. Anything multiplied by 0 is 0, and 0 squared is still 0 multiplied by anything is 0. So that means c is 0.5. So that means I can go to my equation now, erase c, and replace it with a proper value, 0.5. Right. Now here's what they want us to do. They want us to prove or to show that it comes instantaneous to rest when time is 5. So when something comes to rest, my velocity, so I'm going to erase my v and replace it with 0. And I am going to solve for t. And when I solve for t, I'm really hoping that one of my answers is 5. And once I get 5, that's the end of the question. Now this is really a quadratic equation. So when I solve the quadratic, I'm going to be using the shortcut on the calculator, but you might have to, I'm not going to review on how to solve a quadratic equation in this video. I made numerous videos on solving quadratic equations. You can just type in iLoveLessons, one word, no spaces on YouTube, because that's the name of the channel, and just type in quadratic equations, and you will get a good few videos showing you how to do it. All right. So, according to this quadratic, the number touching t squared is minus 0.3. So, this is my a value. The number touching the t is my b value. And, well, this is my c value. So, if you have a sharp DAL, you just press mode 2, 2. It would ask you for the value of a, which is negative 0.3. Press equal. B is 1.4. Press equal. And c is 0.5. Press equal. One of my answers, the two values for t here, I'm getting negative 1/3, and my second value, t, is 5. This value is invalid because you cannot have negative time, so we take the positive value. And that's the end of the question. All right, guys? So I'm going to do another question now on kinematics involving integration and differentiation. Hi, and welcome to my second question on kinematics involving integration and differentiation. All right, so let's jump straight into it. Give the question a read. I already started to draw the question for you guys. So I'll just give it a breakdown of the question. There's a point A, and there's a cyclist. Now, they said the cyclist starts from rest at point A. So immediately, I know if he starts at rest, the velocity is 0, and since the question has now started, that also means the time is 0. So I put my values for the starting of the question, and they say that at point A, he starts at rest, and then he travels, but he comes to rest at point B. All right, so that means he stops at point B. So that means at point B, if he comes to rest, that means his velocity here is also 0. But obviously the time is not 0 because time has passed between point A and point B. So the time at point B, for the time being, I don't know the value. And they gave you an equation to represent the velocity between point A and point B. All right, so let's see what they're asking. They want to know the time taken in part 1, the time taken for the cyclist to travel from point A to point B. Oh, well, great. That means they're trying to find the time at point B, sorry. So this here is the expression for velocity, which was given to you in the question. And anytime something comes to rest, the velocity is 0. So what I'm going to do is replace the velocity with 0 here and solve for t. Now, when I solve for t, right, I'm supposed to get two values. One of the values is supposed to be t is equal to 0, because when t is equal to 0, the velocity is equal to 0. But there should be another value of t that will make my velocity be equal to 0. So if I replace, well, I replaced the v with 0 already. And to me, this is just simply, to solve this should be real simple. We just need to factorize out the t. So you'll get 6 minus a half t. And we just need to put each section equal to 0. Put this section equal to 0 and put this section equal to 0. And solve for t. But this one here, when we solve for t, which doesn't require much work at all, we see t is 0. There should be another value of t. Let's solve for t here. Throw across the minus a half, get a positive a half t. Take the 6 and divide it by a half. T will be equal to 12. So when the time is 12 seconds, the velocity is also equal to 0. Right? So there are two values of t that have a corresponding velocity of 0. So that's part 1. So the answer for part 1 was 12 seconds. All right, let's see what else they asked us here. They said the distance from A to B. Well, if I have the formula for velocity and I'm trying to find distance, that means I have to travel upwards, which means I need to integrate velocity. So let's do that. If we integrate velocity, we get this, well, displacement, right? Integrate this is ready, t to the power 1, add 1 to the power, divide by the new power. Same thing here. You have a half t squared, add 1 to the power, divide by the new power, right? A half divided by 3 will give us 1/6. You can try it on a calculator, but I'm correct. And 6 divided by 2 is 3. So let's just clean this up. And since I integrated, I need to put plus c. So I need to figure out the value of c. Well, let me clean up here first. 6 divided by 2 is 3. A half divided by 3, like I told you, it's 1/6. Okay? Great. I'm going to neaten it up here. All right. Cool. So we need to find the value of c. Now, remember at the beginning of the experiment, when it was at point A, your displacement was 0, and at that time, t was 0. So I can easily solve for c here. I just have to replace d with 0, and when the distance was 0, the time was always 0. But if we do that, if we replace this with 0 and all the t's with 0, and we solve for c, we will get c is 0, right? So my c will be 0, but I'm not going to put plus 0, okay? Right, so we now have an expression for the displacement. They want us to find out the distance between A and B. How much time has passed between A and B? 12 seconds. So I just have to replace the t with 12, and that will give me the corresponding displacement. So let's do that. D is equal to 3 open brackets 12 squared minus 6 open brackets 12 to the power 3. I'm just going to work out this straight on my calculator. Let's see. 3 multiplied by open brackets 12 squared, right, minus, well, let me do this piece by piece. Seems to be a little bit tedious here. So 3 multiplied by 12 squared is 432. I'm going to put in 12 cubed and then multiply by 1/6. So 12 to the power 3 divided by 6. I'm going to get 288 here. Just double checking my answer. Yep. When we work this out, when we minus these two, we are going to get 432 minus 288, 144. So the answer for part 2 is 144. So the distance between A and B is 144 meters. All right, the acceleration. To find the acceleration, let's go back to the original formula they gave us, which was this. All right. Remember, if you have velocity and you require acceleration, you need to move downwards. So I need to differentiate this expression to get acceleration. So when you differentiate v, you will get dv dt. dv dt is the same exact thing as acceleration, right? When we differentiate 60, we'll just get 6. Throw the 2 in front, the 2 will meet the half to get a 1, and we minus 1 from the power. So we will just get minus 1t when we differentiate. But nobody puts 1t, they just put t. Okay? And they want to know the acceleration when t is 8. So all we have an expression for acceleration. All we have to do is go and replace the t with 8. So we end up with 6 minus 8, which is equal to minus 2. That means his acceleration was minus 2 meters per second squared. That's the unit of acceleration. So since the acceleration was negative, this is actually a deceleration or a retardation. Okay? So that's the end of the question. Now, I'll be really honest with you. Questions like these that come for the CXC exams are usually not harder than this. I would consider this a hard question, right? So it's either you're going to be integrating sometimes or differentiating sometimes, okay? So I know for the AdMath syllabus, you usually have a choice between the probability and statistics or kinematics. My advice, guys, choose the kinematics. It's way easier in my opinion, even if you're a business student and you're not doing the physics. These series of videos on kinematics will be perfect for the CXC AdMath examination, right? It has the same difficulty as the questions that will come in the exam, probably a little harder, in fact, in my opinion. All right, so guys, good luck in the exams, right? And of course, if you're interested in extra lessons and you're from Trinidad, you can just call me on this number, and we'll see if we can find a suitable time and class to suit you. Take care, guys.